Hello everyone, thank you for watching Edupedia World videos. So, in the first section of this topic, processing requests in application server ABAP, we have seen an instance, the architecture of an instance. We have seen like what are the components of various work process, and the dispatcher, what does it do, and next the shared memory, what does it contain in an application server. So now here we will see the different types of work process in the ABAP system. So we'll see the dialog first, then we'll move on to the lock, that is the enqueue work process, and we'll see the update work process, the other work process, that is the spool, batch, and the other services like the ICM, the gateway service. So in the first one we'll see about dialog, lock, and enqueue. In the next session we will see about the other work process, pool, batch, and the services. Okay, so the gateway service, the ICM. Okay, those two we'll cover in the next topic. Now, dialog request processing. A program dialog step is assigned to one specific dialog work process during execution. The individual dialog steps for a program consisting of several screens can be executed by various dialog work process during program runtime. This is called work process multiplexing. A dialog work process sequentially processes dialog steps for various users and programs. So the very important work process is a dialog work process. Every SAP instance should have at least 2 dialog work process. So I mean like every instance. Okay, if an SAP system has n number of instances, then every instance should have at least 2 dialog work process. So this does the actual processing. Whenever any request is initiated from the user, first it goes to the dialog work process. And in an ABAP program we can have n number of dialog steps. Okay, so that means like the program is divided into different subunits. Okay, the smallest one, which is undivisible, is termed as a dialog step. So each dialog step in the program can be executed by a different work process. So if we have n dialog steps in a program, okay, from here to here, each dialog step is executed by a different, it can be executed by a single one, or it can be executed by different dialog process. So this technology is known as work process multiplexing. A dialog work process sequentially processes the dialog steps for various users and program. Okay, so one dialog work process different dialog steps for different users and different programs. Now, how this dialog step is identified and how the information is transferred from one work process to another. This is identified by 2 key parameters known as PBO and PAI. PBO stands for process before output and PAI stands for process after input. So what is this PBO? This is processed before the screen image is sent. This part logically belongs to the subsequent screen image. So this PBO is nothing but once a processing is over, like in a dialog step, like what screen will be produced as the result. This is known as PBO. Now PAI, this is processed after a user interaction on the screen. This part of a dialog step logically belongs to the preceding screen image. So once an user interaction is made, okay, the beginning of the dialog step is denoted by PAI. So what all inputs we get for processing that particular screen is termed as PAI. So first we get a PAI to a dialog work process. It does some processing, and whatever that PBO, the last screen of the dialog step, is sent as an input to the other dialog work process as a PAI. So it completed one dialog processing, it is sending it. It does some again processing. This is a dialog step again identified by PAI. Now screen 105 is the last screen of that dialog step. So that is again sent as an input to the next dialog work process. Okay. Then again it does some processing, and a same dialog work process can also process the subsequent dialog step. In that case, again that PAI input is taken in the same dialog work process. So nothing, you give the first screen of input, last screen of input, PAI, PBO first, okay, and this is last. Okay, so in between there is some processing, and this PBO is again sent to the next dialog work process as a to the same one, or it can be sent to a different work process as a PAI. So the screen information, like what program is executed, what is the user, okay, which is running this program, this is stored in the user context. Okay, so that's how when the work is transferred from one dialog work process to other, this information is fetched from the user context. Okay, like what object it is, what program it is, and what user it is. Okay, all the information in that screen is fetched from the role area, the user context, and it is taken as an input for the next dialog work process. So in an entire ABAP transaction, you can have your transaction processed by n number of dialog work processes. Okay, this is known as work process multiplexing. That is how dialog work process work in an SAP system. And the first and the last screens are defined by PAI and PBO, these two modules. Now, the actual processing logic of the ABAP programs is executed by the ABAP interpreter. The actual processing is done by the ABAP interpreter. The screen processor informs the ABAP processor about the subprogram that needs to be executed, which depends on the processing state of the screen flow logic. So these two we have learned earlier, like the ABAP interpreter executes the program, and the screen processor, it tells the ABAP interpreter like what is the subprogram which has to be executed. If data needs to be exchanged with the database or buffers during dialog step, this exchange takes place through the database interface. This enables access to database tables, ABAP programs, or ABAP dictionaries, etc. So the database interface converts like OpenSQL to native SQL, and whatever it is, like whether it has to access a buffer or the database, is taken care by this database interface. And the internal coordination is done by task handler in the work process among all these components. So that is what about dialog work process. Okay, so the first element which comes into picture for processing in an SAP instance is the dialog work process. Now, updates. Now, in database, like we read, sometimes we do updates, like many times we do updates to the database. We do some insertions, deletions, and updates. So any change which is made to the database, okay, this is known as updation. Now, transactions are processing units that functionally belong together. They have the following principal characteristics which together form the acronym ASET. Now, in a relational database, okay, every transaction has to follow some particular characteristics. Those are known as the ASET properties. Okay, this is very important. That is, it is atomic, consistent, isolated, and durable. Atomic. A database transaction is a non-divisible sequence of database operations at the beginning and end, of which the dataset on the database must be consistent. Okay. The beginning and end of a database transaction are defined by a commit command, database commit to the database. During a database transaction, that is between two commit commands, the database system itself ensures that the dataset is consistent. Okay, atomic means a database transaction. Okay, here we are more bit going into the database transaction. So database transaction is nothing but it's a non-divisible sequence of database operation. Okay, so at the beginning and the end it is identified by a database commit command. So it is atomic, means it is the minute one. It is not indivisible database operation. It is consistent, that is an n number of database operations running in the database system. Okay, irrespective of dependency or if they are independent, the database system itself ensures to be consistent. Okay, then isolated, the database system itself takes care on the task restoring the dataset to its previous state after the transaction has terminated with a error or a rollback. Okay, now in this consistent there is one more point. Okay, so if something has resulted in the database operation is an error, resulted in an error, then it rolls back to the previous state, thereby resulting the entire database to be consistent. Okay, isolated means until the database operation completes, okay, fully, whatever the changes are there that are not visible to the other database operations. See, like one database process is making an update to a table, say like row 1 column 1, here R1 C1, here the value is X, it is making a change to the X. So until that database operation completes fully, so whatever changes it made to that value, they are not visible to the other database operations. Okay, so they will see only that old value only. So until this commit command of this database operation at the end commit has completed successfully. If it fails, then again it will roll back to the previous state. And the database transaction is durable. Durable means like once the changes are made successfully, the data is permanently stored in the database. Okay, so that is durability. So every database transaction, because the database is the backend for an SAP system, a relational database. Okay, so they have to satisfy the database operation, like a transaction, database transaction has to satisfy all these four properties: atomic, it is consistent, it is isolated, and it is durable. Now we'll see the relationship between this database and SAP transaction. In SAP, I have just mentioned before, like the smallest indivisible unit is a dialog step. Okay, and in database that is known as database transaction. So an abap transaction or an SAP transaction can have n number of dialog steps in SAP term, or it will have n number of database transaction in database terms. It is not necessary that the execution of a SAP transaction takes place within a single dialog work process. You can process a dialog box by various work processes, multiplexing of work process. Each work process sequentially handles dialog steps for unrelated applications. So an abap transaction is a set of dialog steps where each dialog step maps to a corresponding database transaction in the database level. Okay, so one abap transaction will have n number of database transactions. So this is the relationship between a database and SAP transaction. Now, log management. So the first work process which we have seen is dialog work process. This is the second one. This is the enqueue work process which is used for log management. To ensure data consistency within an SAP system, you must ensure that more than one user cannot access and change data records at any one time. The SAP system has its own log management concept. From a database perspective, every dialog step forms a physical and a logical unit which is referred to as a database transaction. The database log administrator can coordinate only this type of a database transaction. Okay, so abap transaction is a superset of n number of database transactions. So the database administrator, he will know the work of the database in terms of database transactions only. Okay, so the database will take care of locking from database transactions point of view only. But whereas an SAP, an ABAP transaction, it's a business process, one business a transaction, that is. So in that, for that, the locking management at the database level is not sufficient. SAP has its own log management, and that is taken care by this enqueue work process. So that's what, from the SAP point of view, however, this is not sufficient. This is because the SAP transactions that are formed from a sequence of logically related work steps which are consistent in business terms are generally made up of several dialog steps. So in SAP point of view, you have to take care of locking at the ABAP transaction level. Database will take care of its locking in the database transaction level, whereas SAP has to take care of its a locking at ABAP transaction level. So that's why SAP also has its own lock management. Okay, so that's what SAP systems need to have their own lock management. SAP implements this by using the enqueue work process. This also ensures that the platform independence of the lock management is maintained. The SAP lock concept works on the principle that SAP programs make log entries for the data records to be processed in a log table. Log entries can only be made if they do not exist in the log table. The enqueue work process manages the logical log of the SAP transactions in the log table. You can locate the log table in the main memory of the instance where the enqueue work process is configured. And the instance for which the main memory contains the log table is also known as the enqueue server. So SAP maintains all this locking, whatever logs, the history of the logs and the current logs, etc., in a table known as the log table, which is present in the main memory of the SAP application server. Now this enqueue, wherever that enqueue work process resides, in that same instance that log table is created. Okay, so every SAP system must have at least one enqueue process, and it can have more. If we have more than one, all those enqueue work processes have to be configured on the same instance, same application server, because the log table resides in that particular instance only. So only one instance will have the log table where the enqueue work process or one process reside, and that is also known as enqueue server. Now, example, see the Smith. He is trying to do some change in the ABAP database. Okay, so that will be recorded in the log table via this enqueue work process. So whenever a change is being made, so the enqueue work process gets triggered, this ABAP dispatcher through the message server, it will contact this enqueue work process and an entry will be made. If this mayor is also trying to access the same data record, this enqueue work process will check. If he is trying to change it, then this enqueue work process will check in the log table and it will tell the dialog work process that a log is there. So this mayor will get only read-only access to that record. Okay, this is how locking works. So the enqueue work process will take care of the log management in the SAP system. Now we have different types of log modes. In the application developer, that is the ABAP developer, they will use these types of logs in the programming. The first one is write log mode exclusive. Only one user can edit the log data. The requests for another write log and another read log are rejected. A write log protects the logged object against all types of other transactions. Only the same log owner can set the log again, that is accumulate. So what do you mean by a write log? While editing the data, this write log is kept in change mode. Okay, so all other read and write logs will be rejected in this case. The next one is read log. Several users can have read access to the log data at the same time. The requests for additional read logs are accepted even if they are from other users. A write log is rejected. So a read log means it's only a read access. So multiple read logs can be placed on the same record. Okay, So additional read logs are accepted, but a write log is rejected. Enhanced write log, log mode exclusive, non-cumulative. While the same transaction can successfully request and release the write logs, you can request an enhanced write log only once, even by the same transaction. All other requests for logs are rejected. Okay, this enhanced write log means like the same transaction is requesting write log now and again. Okay, in that case an enhanced write log is kept. Okay, and all other, if like any read or write logs will be requested, they will be rejected. The next one is optimistic log mode. Optimistic logs respond like read logs at first and can be changed to write logs. An optimistic log is set if the user displays the data in change mode. Optimistic logs on the same object do not collide. If the user wants to save the changed data, the optimistic log must be changed to a write log mode. This fails if someone sets a non-optimistic log on the object earlier. Other optimistic logs on the object are deleted in this process. So optimistic log means like you have opened some screen in changed mode in the transaction, and in the next screen you are trying to do some read action. Okay, so first like it's internally read, but the overall transaction is having a change mode, so that is somewhat like an optimistic log. Okay, so this optimistic log will be later changed to a write log. Okay, so that type of log is known as optimistic log. So here if somebody sets a non-optimistic log like a read or a write log, then this optimistic log will be deleted in that process. Okay, so don't worry much about what are the types of logs. Basically write and read everybody should know. Write means a changed mode where all other logs are rejected, and read means read transaction, n number of read logs can be placed. Okay, those two are important. Okay, so the application developer in the programming, they'll decide like what type of logging has to be done. Now, and not only the application developer, okay, the system itself takes care of, by the action we are doing, it will set that corresponding log. The logs set by an application program are released either by the application program itself or by the update program once the database has been changed. Logs that have been passed to an update work process are also written to a file at the operating system level and can be restored if the enqueue server goes down. So the logs set by an application program, they are released once the program completes, okay, or when that update program is completed. And the logs which are passed to update work process are also, they are written to a file at the operating system. Okay, so what all logs are held by the update work process, they are also written to a file at the operating system. Okay, because they can be restored if the enqueue server goes down. Now, the removal of log, there are two ways of removing the logs held by users. First one is ending the user session in the user overview transaction SM04, and next one is manually deleting the log entries in T code SM12. So we have different database SAP transactions, that is SM04 and SM12. In this SM04 you'll see the whom were like all the users which are logged on to that instance. So there if you delete that user, then all the logs held by the user will be released. Similarly, in SM12 transaction code, SAP transaction code, you can go and manually delete the log entries. Okay, but while manually deleting the log entries in SM12, you should be careful. If the user session is active, then you should not delete the log. It will lead to data inconsistencies. Okay, just so sometimes like due to some network issue or something, the user the session will look like active in the SAP system, but ideally he is not active. Okay, so in those conditions, then you have to check with the user, and then old logs like some 2-3 days old logs, okay, if you find them, then you have to check with the users like whether they are really active in the system or not, and then only delete them in SM12. And we should never ever delete and the logs which are held by active users. Okay, sometimes when because of this work process multiplexing, at one point of time you might not find that user active in the system, but a log will be there in SM12. Okay, maybe like some that whatever process is waiting for some event, or it's like in sleep mode or something. In that case, you shouldn't just like you're not able to find an active session simply at for 1 second or something, few seconds, you shouldn't go and delete the log. Okay, so that's why you have to check with the user before deleting any log in this SM12 transaction code. Okay, so these two are the ways through which we can delete the log entries. So the enqueue work process takes care of log management. Now the third type of work process is update work process. So that is the update processing in SAP. Asynchronous updates in SAP offer increased security and performance. The updating system also offers the ability to restore data during the execution of database changes. If data that is temporarily stored for processing is passed to an update work process for further processing during the dialog execution, the dialog work process does not wait for the update request to be completed. The update is asynchronous, it's not simultaneous. The dialog part completes with the abap command commit work, and the update part of the transaction starts. Now, the update work process takes care of updates in SAP. Like if any changes to the database had to be made, those are not done by the dialog work process. Just to lessen the burden of dialog work process, this update work process have been introduced. Okay, so the actual changes to the database will be taken care by this update work process. Now, once the dialog work process completes its processing, and it encounters the abap command commit work, then it will hand over that update processing to the update work process, and these update work process go and make changes to the database tables. Okay, so like this is an abap transaction. So these are the individual dialog steps. So after completion of this dialog step, okay, the commit work, okay, the abap statement commit work came. Okay, so then the update work process will come into picture, and it will take the input, that is like whatever this PBO output is there. Okay, it will take the input as PAI, and it will take care of the updating. So that's what SAP updates are asynchronous in nature. So once the dialog work process completes its part, it will hand over that updation to the update work process, and it will be again free. It will be available for another processing. Okay. Now, so like n number of dialog work process will, if they have some updations to be carried out, they will leave all that to the update work process. So for this updations to be taken care and be consistent, we have different tables. All those update tables, they start with VB HDR, update header, VB mod, update modules, VB data, update data, and VB error, the error information. The table structures can be displayed using the abap dictionary. So we have different types of update tables. Okay, so all these update tables, they maintain the information about the updates which have to be processed in the system. Okay, so all the updates which have to be processed will be piled up, and one by one the update work process will, if you can have at least, you should have at least one update work process in an SAP system. Okay, and you can have more also. In a real-time scenario, for every instance you will have some few update work processes. Okay, so they will take care of these updations. Now we have two types of updates in SAP. Okay, time critical primary V1 updates. These updates are relevant to the objects that have controlling functions in the SAP system, such as change to the material stock or an order creation. So we have V1 and V2 updates. Similarly, we have two types of update work process, V1 and V2. V1 should be there V2 you can configure or not. If you don't configure V2 update work process, then these V2 updates are also taken care by V1 also. Okay, and the next one is non-critical or secondary V2 updates. These updates depend on V1 updates. These updates are, for example, purely statistical updates such as calculation of results. These updates are collected and processed at a later point in time, that is the collective run. Now V1s will be processed first. Okay, after V1 is processed, then only V2 will be processed. Okay, so until the V1 updates are cleared, V2 will not be processed. And V2 also, they'll be, sometimes a bunch of V2 updates will be collected together, maybe because they are dependent on each other, and they'll be processed in a collective run. So that's what. Now this SAP user, he's trying to do some updation task. Okay, then that update work process is on a different instance. So the communication will be made to that update work process. Okay, that update work process will check in this VB star tables like what are the updates, and it does the actual database changes, that is the updations. So once the dialog work process encounters this commit work, okay, then it will hand over that information to the update work process to do the processing. So that's why, that is why SAP updations are asynchronous in nature. Okay, so this is about the update work process. So now in this topic, what we have seen, we have started with dialog work process. Okay, these two have to be remembered, this process after input and process before output. Depending on these two only, work process multiplexing works. Then we have seen this ACID principle: atomic, consistent, isolated, and durable. Okay, so a database transaction should satisfy these four characteristics or principles. Then we have seen relationship between database and SAP transactions, like an ABAP transaction has n number of dialog steps, and each dialog step corresponds to a database transaction at the database level. Next we have seen lock management, which is taken care by the enqueue work process. Okay, so lock table we have seen, where that enqueue work process is there, on that same instance we will configure a lock table where all the information about these locks is maintained. Next we have seen what are the different types of lock modes: write, read, enhanced, write, optimistic locks. Next we have seen how locks held by a program will be released. The third type of work process is the update work process we have seen. So SAP updates are asynchronous in nature. So once the dialog work process completes its task, it will hand over the actual database updations to the update work process. Okay, when it will encounter this commit work command. Okay, then we have two types of updates, that is V1 and V2. Okay, V1 are time critical, V1 has to be processed first, and later V2 updates are to be processed. Okay, so in our next subtopic, okay, so we are left with the spool and the background work process and the services like the ICM and the gateway. Okay, so this is about the work process in SAP. Thank you.